Hello, you absolute legends. How's my drawing going? You've heard people talk about molecules in the body in proportions such as percentages, like how much water is in the human body. You know, we're said to be what, 70, 80% water. I don't know, 90, seems like we're, and it kind of invokes this image of, well, not kind of, but it invokes to me this image that we're like a glass that's filled up with water. Now, it's not chemically or structurally correct, but it does get that idea out there. There is a unit of how we measure the concentration of gases in the atmosphere and also molecules in the body called ppm. ppm, which stands for parts per million. And the visual of parts per million is not a human body filled with like a glass of water, but the visual that kind of comes to mind is like, imagine like a square grid of a million dots. And if something is 1 part per million, then there's 1 dot that is representing that one substance there. Okay? So, and now parts per million. So you have a million parts and 1 part of it is right there. One way to think about these parts per million that works out real nice with masses is the ratio of milligrams to kilograms is a parts per million ratio by definition. A milligram is 10 to the negative 3 of a gram, and a kilogram is 10 to the 3 of a gram. And if you do a little bit exponent stuff, you can work out a ratio where you have 1 times 10 to the 6th, which is 1 part per million. Now let's get to our question at hand right here. You have in your body 4 grams of iron, mostly in the blood and in the muscles and myoglobin and things like that, hemoglobin and myoglobin, but there's also iron that is a cofactor of enzymes that's all around your body. In total, you have about 4 grams of blood in your body, average. This person happens to weigh, this is supposed to be a scale here, not a clock. This person weighs 85 grams. We get a digital scale. This person weighs 85 kilograms. So we will figure out the parts per million of this person by taking the milligrams divided by the mass of the body. I kind of missed a step here. 4 grams of iron per person. Human person weighs 85 kilograms. We need to plug this into milligrams per kilogram. This is grams. So to do a little conversion of grams to milligrams. 4,000 milligrams of iron, they're equivalent statements. And the 85 just goes in there nice and easy because it is no unit conversion set up here. So again, the visual is that if you were to break the human body up into 1 million parts, some of those parts would be an iron atom. And if we have milligrams and kilograms, the whole is in kilograms and the part is in milligrams. We can just divide them up. So 47.05, about 47 parts per million. Now, remember, this number, when you first calculate this out, it's greater than 1. And you're like, and part of me wants to say like, oh, how could it be greater than 1? It's just 4 grams of 85 kilograms. How can it be greater than 1? Remember that it's 47 parts per million. So in your square grid, in your mind's eye of 1 million pieces, there are 47 dots that represent iron and only the iron, and the other 999,963 dots represent the other elements that make up the human body. I hope this helps. Thank you.